Okay, section 5, the IoT application layers and structure. I'm talking about the different application protocol on the data structure for the IoT application. MQTT and CoAP underlying protocol for the IoT. Since the HTTP protocol has overhead, we need to find a solution to send the data over application layer to the cloud from the low power, low cost IoT devices. The important point here is that in all of these use cases, the things must communicate through the internet to be considered an IoT node. So one of the reason the difference between the CoAP and MQTT with HTTP is just the compression of the size, and we were able to send the application layers and port the application protocols to the microcontroller. HTTP is too big, as you know, it's based on the TCP/IP UDP, and it's very big. Than the size of the IP is around 1200 bytes. So the CoAP and MQTT is a RESTful and has been replaced to the HTTP. And one of them is based on the like an acknowledgement, like there's TCP, and the other doesn't. The other one, the CoAP, doesn't have an acknowledgement like a CoAP UDP. The MQTT and CoAP underlying protocol. So the constraint application protocol, the CoAP, which is the most popular one, and I think is the best application protocol, but the best doesn't make sense because it depends on the application we are talking. So the CoAP is the fastest one. So this is very important to reduce the delay. The CoAP is the better protocol than MQTT. The MQTT is older and the CoAP is newer protocol. It's a software protocol intended to be used in the very simple electronic devices like a microcontroller that allows them to communicate interactively over the internet. It is UDP based, and the most efficient application protocol in IoT. It will be replaced to HTTP, HTTPS. As you can see here, the sensor talking through the CoAP to the gateway, and the gateway to the cloud, and data center through the HTTP. So the gateway, IoT gateway, usually should have a kind of integration between the CoAP and HTTP, which is done by the integration between two different stack protocols. The CoAP structure model. The CoAP interactive model is similar to HTTP client-server model. The diagram shows that the CoAP employs a two-layer structure. The bottom layer is a message layer that has been designed to deal with UDP and asynchronous switching. The request response layer concern communication method and deal with the request response message. So as you can see, it's based on the UDP and the message and the request response and application, whatever application you want, you can put it top of that. The message format in CoAP is based on exchange of the compact messages that by default are transmitted by UDP, which is the connection oriented and doesn't have any acknowledgement. That's why it's the faster. CoAP message occupies the data section on one UDP data diagram. Message of the CoAP uses the simple binary format message, like a 4 bytes hardware plus the variable length of the token plus a sequence of the CoAP option plus the payload. This is just a format and doesn't matter. You don't need to pay attention for this. But when you're developing your CoAP, you have to just mention all of these parts of the message in your block of CoAP.